Making thin water films. For wet chemistry lab operations on space station, we need the equivalent of a zero gravity beaker. What we are using here is a 4-inch square Ziploc baggie, which makes a two-dimensional beaker where the opening is a slit instead of a round surface. And you can squeeze the bag to open it up a bit so you can have access to this surface. The slit part of the opening allows surface tension forces to contain the liquid so it won't slosh out and it will be well behaved. Here we're taking a 50 millimeter wire loop and dipping it into the water in our two-dimensional beaker. Now this water is deionized water. It's the purest water we could find on space station. There is no added surfactant. In the process of pulling this wire loop out, you draw out a sheet or film of water, not unlike what you would do on the ground with a soap film. This solution has no soap added to it. You can use surface tension forces to drain this film, and it will be about 200 microns thick. Here's a view of this film with reflected light, and you can see there are no interference colors. This film is too thick to show interference colors. It has sufficient mass so you can drive it into these delightful oscillations where you get these lensical structures forming on each end of the oscillation. Once in a while you can spall off droplets of water, which we will be able to see in high-speed digital still images what the water looks like while it is being driven off of the film. These are similar to, however different than, splashes you would see from droplets splashing under the influence of gravity. Here we have a film caught in the middle of being ruptured.